Good morning, everyone, and welcome. I'm Carrie Burke, your moderator for today's webinar, an OWASP SAMM perspective on serverless computing. You may send in questions at any time during the presentation via the Q&A chat feature. We will collect these and address them at the end of today's presentation. I would now like to introduce Dan Cornell. As Chief Technology Officer and Principal at Denim Group, Dan leads the technology team to help Fortune 500 companies and government organizations integrate security throughout the development process. He is a globally recognized application security expert with over 15 years of experience architecting, developing, and securing web-based software systems. Presenting alongside Dan, we have Ori Segal. Ori is a founder and the Chief Technology Officer at PureSec. He is a world-renowned expert and veteran in application security with 20 years of experience. Ori holds numerous patents in the field of application security. He has also served as an officer of the Web Application Security Consortium and is a former OWASP Israel board member.
Thanks, Carrie. Thanks everybody who's attending here today, and thanks Ori for being working together with us on this webinar today. I'm excited. I think back, Ori, I think that I originally met you when you were either at Sanctum or shortly after the Watchfire acquisition of Sanctum. So you've certainly been in the industry quite a long time, and I've enjoyed the opportunity to work with you in a couple of different capacities. So thanks for participating today.
Same here, and you just exposed both of our ages, so.
Right.
Yeah.
Exactly. And so for folks attending, again, thank you for coming online with us today. And what we're going to be talking about is looking at serverless computing and the security of serverless computing, and using a framework, or using it as a framework for this, looking at it through the lens of the OWASP SAMM, or the Software Assurance Maturity Model. For me, this is something that I've been looking at quite a bit over, in recent months. One of the things that we saw at Denim Group that really accelerated in 2018 was a push in a lot of large enterprises for what has been boiled down, or what is commonly called digital transformation. And so these enterprises are being asked or being forced by the market to do more, and to do more faster, and to do more with less, really driving the pace of innovation. And that has led to a number of cultural changes to support this. DevOps, breaking down the barriers between development teams and operations teams for folks on this call. DevSecOps, integrating security in that breakdown of the barriers. And these transitions are both supported by and driven by a number of technological changes, surrounding the cloud and CI/CD pipelines and things like that. And so serverless computing is an important component of that, and in certain ways pushes a lot of trends that we've seen to the extreme. If you look at the breakdown between development and operations, one of the things we'll see is serverless really pushes a lot of responsibility into the hands of the developers. And so for organizations concerned about application security and software security that are adopting these serverless technologies, there are some really important questions. And as with all technologies, I think the technologies are introduced and adopted, and security is sprinting behind these adoptions, the adoption of these technologies, trying to make sure that they're done in a responsible manner. And so I'm excited to have the opportunity to talk about some of the things that we've seen in this space working with organizations as they're adopting serverless technologies. And really excited to have the opportunity to have Ori on here as well to talk about some of the things that they've seen, as well as the work that they're doing at PureSec to provide the tools and platforms that organizations need for securing these serverless systems. And from an agenda standpoint, we're in the introduction right now. I hope everyone's enjoying that. And Ori's going to talk about an overview of serverless computing security. Again, looking at attack surface, the top risks that organizations have identified, and some of the limits with traditional solutions. He's also going to talk about what they're doing with their security platform in this space. And then I'm going to talk through through the viewpoint of the OWASP Software Assurance Maturity Model, things that organizations should consider as they look at their adoption of serverless, the security thereof, and how that potentially fits into their roadmap for their program from a maturity standpoint. And then we'll have an opportunity for questions at the end of the discussion as well. With that, I think I'll turn things over to Ori to talk about serverless computing and its security implications.
Thank you, and thanks for a great introduction. Trying to define what serverless is a bit hard. If you ask different people, you usually will get different answers, and oftentimes ends up with a big, huge fight over what serverless really is. But I think that most people will agree that behind this concept lies the idea of renting compute as utility. So you basically hand the code for your application to the cloud provider, if we're talking about public cloud serverless, and then sort of bind that code to certain cloud events and have the cloud provider take care of executing and making sure that it scales and taking care of the underlying infrastructure. And so the way it would usually work, if you look at a serverless application, a very simplistic example, in this case, a user could be an end user or a mobile app sending an API request that gets handled by an API server that passes that to, in this case, AWS Lambda function that then runs the code as a response to the event and perhaps interacting with some cloud services in the process. That's the basic concept. Now, looking a bit more in depth into the benefits of serverless architectures, most people will agree on the following. First of all, you don't have to manage any underlying servers and infrastructure. A huge cost savings involved here. The continuous scaling concept, where the cloud provider is responsible for instantiating enough serverless environments to execute your code in response to the different events. So if one user triggers or one event triggers your code, then one container or micro VM or whatever it is under there will execute the code. But if you have a million concurrent executions, then the cloud provider is responsible for continuously scaling that. And that also ties to the concept of sub-second, if I get to switch the slides here. Sorry, there it is. It is a bit slow here. So sub-second metering, where you pay by the millisecond. In most cases, that's per 100 milliseconds, and you don't pay for idle, which is, again, very important key attribute of serverless environments. And last but not least, if you think about, sorry, let's just go back here. One of the biggest benefits is that you don't have to be responsible for securing the underlying infrastructure. So anything from, and we'll see that in the next slide, anything from the hardware, the server racks, the guards, the locks, the networking, all of that is being handled by someone else, and you have a lot less security to worry about. And what you are worried about is mostly the application layer. So as I mentioned, and looking at the shared model of security responsibility for serverless, the cloud provider is responsible for the majority of the daunting tasks that you had to do today, like patching operating systems and taking care of the virtual machines or the containers and the networking security and segmentation and the locations and everything. But you, as the application owner, you are still responsible for securing. Pardon me. Dan, you should take over that. So you are still responsible for securing your own application layer. Obviously, this is not going to change. Nobody's going to assume that responsibility for you, and that includes obviously the source, the functions themselves, the logic, the business logic, as well as the identity and the access management, the roles, the configurations of the different cloud services, and I think we'll get back to that a bit later, that your application interacts with, but also the data, in the cloud and in transit. So that is still your responsibility, and this is obviously the majority of what we're going to talk about in this presentation. Now, we did publish, I actually published a couple of weeks ago, an article at the Dark Reading magazine, comparing the security responsibilities and how they split between the cloud provider and the customer, between EC2 or infrastructure as a service based applications and serverless. You should go over that list. I think it's a very interesting article. But the overall story here is that when you're using basically your own virtual servers on EC2 or things like that, you are still responsible for about 90 or the majority of the security tasks. So making sure that you comply with all sorts of regulations and patching the operating systems and segmenting the network and installing firewalls and anti-malware and all of those. And in serverless, I think, at least according to my calculations, the majority of the tasks are now the responsibility of the cloud provider. From that aspect, serverless is a huge boost to security, and the cloud provider obviously has a much more resources to handle these things. We've seen that with the recent Intel vulnerabilities that surfaced within 24 hours. The entire Amazon cloud was already patched. I'm guessing that organizations will take a few more years to get to fix all of that. So huge benefit from a security perspective. Now, in order to understand the attack surfaces in serverless, I'm going to sort of explain very quickly and in very high level how you actually deploy and how things work in serverless. So it starts with a developer that pushes code to the code repository, Git or whatever you're working with, then deploying that function to the cloud. Then, as I mentioned, there's a set of event sources that can trigger that function, and that depends on the cloud provider. I think the last I heard for AWS, the number is 47 different event sources that can trigger a function, ranging from obviously HTTP, web API calls, but also MQTT, messages coming from IoT telemetry, or database changes in the cloud, or CloudWatch logs that get sent, and so forth. There are plenty of different event types, and each of those events can trigger the function, bringing with it its own data and its own data fields with the different encoding schemes, and then those would trigger the function that will usually do its task. In most cases, these functions are not isolated from the rest of the cloud, and so the function will interact with a set of cloud resources, S3 buckets, DynamoDB tables, blob storage, message queues, and so forth. And everything works well, will generate some output. So how can an attacker even access your functions if they are stored in your cloud account? And we at PureSec sort of enumerated some, or the most common attack surfaces that will allow an attacker to manipulate your business logic. So the easiest to understand is the event data. So the event that triggers the function can bring with it user or attacker controlled malicious data. And I mentioned, if it's an HTTP REST API call going through API gateway, then obviously we're talking about parameters or cookies or headers. But if we're talking about other types of messages like WebSockets triggering your function, or somebody changing a file in a storage bucket on the cloud, that can also trigger the function. And within those data fields, an attacker can inject malicious data. So that's one path in, and that's the easiest one to understand. The second path is through unauthorized code deployment. And if you think about it, all an attacker has to do is sort of phish one of your developers or run a cross-site scripting attack, steal the session or the credentials for your cloud account, and basically deploy code out of band, not through your code repository in your normal CI/CD process. We've also seen mistakes where organizations are pushing code to public Git repositories and forget or leave their hard-coded credentials in there. That's very unfortunate as well. Another way to sort of poison through the code is through third-party open source libraries, and this is not unique to serverless, but the problem gets a bit more complex when we're talking about serverless. So we've seen numerous cases in the past few years where malicious actors poisoned open source libraries. I think the last one I remember was an NPM package that somebody poisoned it with some Bitcoin mining code, and that would run together with your application. The problem with serverless is that you don't control, or until today, you didn't have any controls over the runtime environment in the cloud where your function is running, and so monitoring what those open source libraries were doing and whether or not they were leaking credentials or running code, that's very hard to do. We'll talk about that in a bit. And last but not least, if the function during execution communicates with cloud resources like S3 buckets or database tables, and an attacker has access to manipulate the data there, the attacker will in turn be able to manipulate your business logic. Again, a very simple example I can give is, publicly open S3 buckets. If the function relies on data on those buckets, it's pretty simple for an attacker to manipulate the business logic. And from a goals perspective, the goals are pretty much the same for the attacker as we see in any kind of application layer attack. So compromising data, bypassing authentication, abusing business logic, leaking secrets. Denial of service is another interesting item in the sense that most people think that serverless functions are sort of resilient out of the box to denial of service attacks, but in reality, unless you invest in good design, and make sure that your application can scale and is built to scale throughout all of its components, you may end up finding yourself in a situation where somebody finds a function that they can sort of hog to run very slowly, maybe through an AppDOS attack or a ReDOS attack, and then instantiate enough concurrent executions and choke the account and hit the concurrency limit, which by default is usually 1,000 concurrent executions. So those are the goals for the attacker. Now, if we're looking at traditional application security solutions like web application firewalls or runtime application self-protection, and I'll give a few other examples of more network or host-based security that is also used for protecting application, we see that traditional security solutions require you to deploy something somewhere, either on the network or on the server, on the operating system, in order to provide the application layer protection. Looking at web application firewalls, for example, they need to be located somewhere between the user and the application in order to inspect layer 7 traffic. If we're talking about runtime application self-protection, RASP, you need to deploy something to instrument the underlying application server, web server, and also other solutions like IPS, IDS, endpoint prevention, EPP, EDR. All of those require you to deploy something somewhere. And by definition, in serverless, the application owner has no control over the runtime environment, over the network, the hosts. They are non-existent for the application owner. That's the whole purpose of serverless. And so traditional security solutions are becoming unsuitable for providing application layer security for serverless applications. And to put that into a diagram, if today you build an application and you want this kind of 360 degrees, airtight protection, you deploy an endpoint prevention on the host to inspect behavioral anomalies. You'll install IPS on the network, next-gen web security gateway to inspect outbound traffic going out from your application. As well as obviously a next-gen firewall like Checkpoint or Palo Alto to inspect inbound traffic. And then obviously you add a web application firewall on layer 7, and you put all of that on some infrastructure. And when you go serverless, you basically break up the application into functions, deploy them directly to the cloud. The underlying infrastructure is gone, and your functions are basically sitting there in the cloud, which we can call it the internet. And just as users can access your business logic, so can attackers. And so without any kind of serverless native application layer protections, your app security is reduced to just good coding and strict configuration. And while obviously that can go a long way in solving most of the problems, I'm sure that everybody will agree that you won't feel secure, or you won't have the right level of security if you won't have any kind of runtime protections and logging and monitoring that is tailored to that specific use case. A quick word, and this is actually something that I'm really glad we have a chance to mention. So today, and this is everyone on the call. This is the first time you're the first people to actually hear about this. We are launching together with the Cloud Security Alliance, the CSA, the 2019 Serverless Most Critical Risks. The top 12 list, and Dan, you took a part in writing the original one from last year, the top 10, as well as contributing to this one. So first of all, thank you. And go ahead.
Oh yeah, I believe I was the one who suggested that it be called financial resource exhaustion. So that is my contribution to the body of work that is out there. I think that was my suggestion. So
you should trademark that. Yeah.
Exactly.
So instead of a top 10, we went with the top 12. There are a few other things we've learned during the past year. The first guide was a huge success and got a lot of publicity and a lot of great adoption from folks in the serverless community. I think this one is probably the most extensive work I've seen on serverless security. And we're hoping that this will be adopted similar to how the last one was adopted last year. So there's a link here to download the guide. We won't go through the entire top 12 today. I think we can probably dedicate a webinar for for this document on its own. So let's quickly continue. Really, in less than a minute, a little bit about the PureSec serverless security platform. So PureSec was founded in 2016 with the sole purpose of building the next generation of application security solution tailored specifically for serverless. And the way, the holistic view behind, our view of how you should be doing serverless security, we divided the platform into three main pillars based on the different points in the lifecycle of serverless applications where we believe we can, help organizations to secure. So starting during CI/CD, and again, we'll touch on all of this later on when we talk about SAMM. So during CI/CD, the serverless security platform, the PureSec platform, provides organizations with a very unique static analysis capability tailored specifically for serverless applications. This is not a replacement for traditional SAST tools, like the checkmarks or Fortifys of the world. It is tailored specifically for serverless-oriented problems like bad IAM permissions, list privilege issues, cloud security posture management, known vulnerabilities in open source libraries inside serverless environments. And so you can scan the code as early as, on the developer's desktop, and then as part of the build and fail the build in case it doesn't meet your corporate security policies. And you can also periodically scan all of your serverless assets that are already deployed in the cloud. And the purpose here is to make sure that what you're building is as resilient as possible from the get-go. The next layer, the runtime protection layer, is attached to each function. The concept is very similar to OWASP. However, obviously you can't deploy an instrumentation agent. So we're using a different approach where you attach to the code. You can do that either by adding one line of code to each function, like import PureSec, or by using the latest capability from AWS called Lambda layers. That's basically just a configuration change that you point your function's code to the PureSec runtime protection layer. And when the function starts running, and it doesn't matter where it runs, if it's inside a local container on the developer's desktop or in the cloud, it will generate a security perimeter around each instance of the function, which is obviously serverless by itself and scales together with the different executions of the same function. So there's no single point of failure, a single bottleneck. And the first layer of protection is a serverless application firewall, very similar in concept to web application firewall. However, it intercepts the cloud-native event trigger that goes into the function, inspects it rigorously for injection-based attacks, classifies it, decodes it to find things like SQL injection, path traversal, runtime code injections, things like that. And because it's attached to each function and works on the event, the cloud-native event, it is not tied to a specific protocol like HTTP or HTTPS. It can detect attacks in any kind of cloud-native event. So anything like SNS messages or emails or S3 buckets that trigger a function, or Kinesis data streams or APIs or WebSockets or whatnot. And the purpose here is to make sure that when the function starts executing, it's executing on trustworthy data. Now, assuming we didn't find anything malicious in the input, we allow the function to start running, and then the same runtime protection library is now running a behavioral protection engine to make sure that the function behaves as intended using a machine learning model. So it monitors what the function is trying to do, how does it interact with the outside world, with cloud services, with remote hosts on the internet, as well as how it is behaving inside the local serverless runtime environment. So is it accessing the file system? Is it spawning child processes, running malicious shell commands? And when it detects a malicious behavior that's not intended, not normal for the function, it will then and there block that activity and report back, both back PureSec console where you can sit, or to SIEM systems or Splunk or whatever it is that you're using for security event and response handling. And the data that you're getting is extremely rich. So usually data that you wouldn't get from the cloud provider about what's going on inside the operating system, the runtime environment, who your function is communicating with, and we see a lot of customers using that to gain confidence in third-party open source libraries that they don't necessarily trust. If they want to block the function from communicating outbound to the internet and only allowing it to interact with cloud services, that's also possible. So that's the fastest I can go over the serverless platform. And we'll go through, when we talk about SAMM, the different areas where PureSec can also provide value. And I think I'm done with with my part, and go ahead, take it away.
Yeah, very good, thank you. And so kind of given that background on serverless computing and the security implications of serverless computing, wanted to talk through kind of briefly talk through the OWASP software assurance maturity model, and then talk through some of the areas where we have seen in interacting with our client organizations, where we've seen the introduction of serverless computing have an impact on their plans from a maturity standpoint for their application security program. So, for folks who may be more or less familiar, the OWASP software assurance maturity model, it's one of the OWASP flagship projects. OWASP has a number of projects that they maintain, but the maturity of this maturity model puts that at the top level. And so there have been a lot of contributors across the industry, across vendors. OWASP SAMM has been out there for a number of years, and so it's a project that we've been participated in for a long time and found a lot of value, and a lot of the organizations we work with have found a lot of value in this. And the purpose of OWASP SAMM is to provide an open framework to help organizations formulate and implement a strategy for software security that is tailored to the specific risks facing their organization. And the two most common ways that we see organizations use OWASP SAMM is first to take a look at what are we doing in our software security program, and how do I characterize our level of maturity based on the practices that we have and how pervasively those practices have been implemented. We also work with organizations in a number of cases to help set goals, to say this may be where we are right now, but because of our particular risk profile, this is where we want to be. And what it allows organizations to do is to set some pretty specific goals for practices to adopt and how to see those practices adopted across their organization. Just from a structure standpoint, one of the other things I like about OWASP SAMM versus other maturity models is it's a fairly straightforward and tractable model. If you think about things like the Software Engineering Institute's CMM or CMMI, for the maturity of development practices in general, those are pretty elaborate or Baroque standards, and I think that has caused the adoption of those to be limited to environments where they place enough value on tracking maturity that it makes sense, or whatever the economic drivers are in place that have made it make sense to adopt those. And so you see a lot of that in the government space and a number of the offshore dev shops to demonstrate the maturity of their development practices, not necessarily related to security. Again, with OpenSAMM, I think the structure helps make it applicable to a wider range of organizations. And so if you just to look at the structure, SAMM breaks down the world of software security or application security into 4 business functions. So looking at governance, how are we structuring and managing our program? Looking at construction, what practices do we have while we're building software? Looking at verification, how do we test the software that we built in order to make sure that we accomplished the security goals we set out to have or to accomplish? And then operations. Once we put these systems into production, how do we need to instrument those processes or work with those teams in order to make sure that we maintain the security state of the system that we want? When we break that down further into the specific security practices, so looking at strategy and metrics, what's our overall strategy for the program and how are we tracking, from a quantitative standpoint, how are we tracking our success? Policy and compliance, looking at how do these activities that we're undertaking for application and software security, how do those map to the particular compliance and governance requirements we have in our organization? Looking at education and guidance. When we have developers building software, how are we providing them with the materials they need so that it's reasonable for us to expect them to be successful? Moving to construction, looking at threat assessment. What's the risk profile for our organization for the applications? What type of attackers do we expect to see? And what are the attack vectors we expect them to use? Security requirements. How are we being explicit about the security requirements of the systems that we're building? And then secure architecture. How do we want to fit together building blocks in these systems that we're building so that we can bake in the security properties that we expect to see? Moving on then to verification, design review. Once we've designed a system, how does someone come in, look at that design and say, yes, I believe this design is going to result in a system that has the security properties that we want? Implementation review, essentially code review. How do we look at the specific implementation to make sure that we don't have code level bugs, and doing this by inspecting the implementation or the code or the binary? And then security testing. How do we test from the outside in order to identify potential weaknesses and vulnerabilities in the software? Moving on to operations, issue management. When we inevitably find problems, especially with systems that are in production, how do we handle and remediate those issues? Environment hardening. How do we, software doesn't exist in a vacuum. It has to be deployed into and run on infrastructure. How do we harden that infrastructure that supports these applications in order to support the software security? And finally, the operational enablement for the teams that are responsible for the ongoing operations of the software. How do we need to interact with them in order to support them in achieving our security goals? And so, again, with the SAMM structure, I like it because there's 12 things you have to pay attention to. That's a number of things that I can, keep track of inside of my head, or at least in a short enough document. And again, I would contrast that with the kind of sprawling nature that you see of some of the other maturity models, again, not necessarily in the security space. But this is a tool that we found to be very handy with organizations. Again, once they have a program up and running, to say, let's take a look at our program and be honest with ourselves about its level of maturity, and let's set goals for ourselves based on the particular risk profile in our organization. And then maturity gets ranked for each of those 12 security practices from 0, which is we're not doing anything, all the way up through 3, which is we have a mastery of this and we have scaled it across our program as a whole. And we're not going to get too deep into the maturity ranking here, but what I will try to highlight are situations where there are certain aspects of serverless that are, where there are particular opportunities to get maturity. For free is probably the wrong way to characterize it, but where there are particular opportunities where you can advance from a maturity standpoint using platform available tools. If it makes sense in those situations where you can use that to drive or to help keep the serverless practice that you have at pace with the other software development work that you're doing. And again, so from an OWASP SAMM standpoint, breaking down the world into the business practices: governance, construction, verification, and operations. And then looking particularly at governance, strategy and metrics, policy and compliance, education and guidance. And so when we look at serverless from a strategy and metrics standpoint, one of the critical things to understand, and I think this is the case for the technological implications of digital transformation in general, and most specifically the move to the cloud, and serverless takes this even more so, is that we're taking agency away from people in your organization who may have been the network or operations staff. And that agency is being handed off to people in a development role. And that's a transition that has been going on for a number of years. And again, I think serverless takes that to a pretty significant extreme because, as Ori identified, with serverless computing, you don't have to worry, like you're worried about your code and you're worried about the configuration around your code. So that puts even more control in the hands of developers. And so that makes it even more important that these developers and these DevOps teams be DevSecOps teams where they also understand the security implications of what they're doing. The big changes that we see here are questions about, as you have hopefully, in the past or up to this point, you have laid out your data classification policy, and you have a way that you do application risk ranking. You've got a methodology for that. It's important to be explicit about the way that you translate that into a serverless environment. And so as your applications that maybe used to be monolithic, after these monolithic applications that were so hard to secure, you broke them up into 30 different microservices, which I'm sure is 30 times easier to secure. Now you're breaking applications down into just like chunks, into individual functions. And so it's important to understand as the composition of your applications have changed, how that is going to impact the data classification. And that's something we'll talk about more here in a second. And it's also a question of how do your established security metrics translate into a serverless environment. So if you're tracking something, and this is not to advocate it, but if you're tracking something like vulnerabilities per kiloline of code or something like that, making sure that this code and the analysis of this code also feeds up into those metrics that you're tracking. And from a metric standpoint, there's an increasing number of, a good thing is there's an increasing number of cloud-native tools that track different metrics. A lot of times these are more operationally focused, performance management, things of that nature. But the good news is that the tooling around serverless, is getting better, and so there may be metrics that you can track automatically, so if there are things you can track automatically that also provide value, this is an opportunity as you move into serverless to say, how are we going to leverage the tooling that exists out there in order to feed up into the overall metrics that we're using to track the evolution of our practices. When you look at, from a policy and compliance standpoint, the really important thing to do is to characterize which workloads and data are acceptable to be pushed into these serverless environments. And again, this is an extension of what we've seen of questions about what data can go into the cloud at all. This is going even further to say, what data and workloads are we going to be willing to run in these environments where we have no control, where the management of the underlying servers is handled by someone else that is opaque to us. It's not something that we can touch. And again, from in certain organizations that may be a lot. In other more regulated industries, that may be more limited, or it may be limited based on the serverless provider that you're considering using. Another area of discomfort that we've found is working to characterize serverless applications or applications that use serverless components to auditors that come in. How do you characterize, and this is certainly not true of all auditors. Many of the auditors these days are certainly getting more cloud savvy. But again, as you extend this to an even greater conclusion with serverless, how are you going to be able to characterize to these auditors, again, these are the workloads, this is the data that runs through these areas, this is how we are protecting those, and how do those translate into NIST controls or PCI or whatever that might be. And again, the good news here is we found a lot of opportunities to leverage platform tools to characterize the compliance critical concerns, especially around things like identity and access management, to be able to show, well, here is our IAM configuration, these are the functions, these are who can touch them, these are the things that they go and touch. That puts you in a situation where you can export documentation or have access to pretty good information about serverless usage and serverless config. Or do you want to maybe talk a little bit about how the PureSec platform helps organizations with policy and compliance questions?
Sure. So I think you touch upon the two critical things that we are hearing from customers that are doing policy and compliance. One is, how do you get a hold of a good view of all your serverless assets. Some call it serverless security posture management or asset management, but being able to, as you said, characterize everything you have, the functions, the different cloud services that they interact with, what are the relationships there, who triggers what, where data is stored, and then, of course, making sure that your IAM permissions and roles that you assign to the different resources and functions are least privileged. Those are the two biggest pain points, and that's something that the first pillar of the PureSec platform deals with, as I mentioned, scanning the environment, scanning your code, scanning the configuration, discovering what you have there, and making sure that you are aware of any vulnerabilities in your infrastructure.
Excellent. Now, next, looking at education and guidance. One of the really powerful tools that we've found for organizations that are making that transition to cloud, greater cloud adoption, and especially security adoption, is to go to development teams and provide them with a reference architecture for these different cloud constructs, including serverless, and to instrument those reference architectures with the security controls. A challenge that we see for a lot of dev teams is they are unfamiliar with how to build systems in the cloud. They have a lot of questions, and there's a tremendous learning curve. And so if you can get out in front of their concerns and provide that type of prescriptive guidance, that's something that they're going to view as extremely valuable. And because, from a security standpoint, you want to use, kind of use their momentum to your advantage. So if their reference architecture is already marked up with security concerns, that means that the way that they think about building cloud systems can already have those security concerns baked in. And so, looking at from a serverless standpoint to say, if you're calling into serverless from the web, here are the controls you can look for. If you're looking at taking the result of a serverless function and putting it on a queue, right? Like, what do those patterns need to look like, and what are the controls that can be put in place? Also, as you get more mature in your organization, the guidance that you provide needs to become more specific to the role of the individual, to the technology that they're using. And so for serverless to provide this environment and language-specific coding and configuration guidelines. And one thing to understand about serverless is there are a lot of materials that are becoming available, but a lot of the stuff that is available right now comes in the form of recorded conference talks, blogs, other things of that nature. The training materials in the serverless space are less mature versus other areas. And so, whereas if you want to train your developers how to build secure monolithic Java web applications, that's a very easy thing to source a number of different providers that can provide that, e-learning, instructor-led training, so on and so forth. When you're looking for serverless, right now at least, just because of the relative or comparative immaturity of that space, you're probably going to be pointing developers to, hey, read this blog post, take a look at this article that was posted, whatever that might be. So that's something to be aware of as you're looking to provide this type of guidance.
And don't forget the top 12 document.
Exactly. Well, there we go. And so when we look from a threat assessment standpoint, this calls upon you to enumerate the likely attacks against the serverless portions of your systems. And there, so your typical web application threat model isn't going to, it just isn't going to apply because it looks different. The good news is, in a lot of cases, for a number of serverless functions, depending on the events that can actually trigger them, they may not be publicly exposed. And so what that means is, certain classes of attackers, it's going to be really hard for them to directly impact the serverless components of the system. And just as we found it to be valuable to provide that reference architecture to developers, we've also found it to be really valuable to provide threat model templates to these developers that incorporate serverless system components. And so to say, if you have a serverless component that is going to be initiated by an HTTP request, this is what you need to be concerned about. If you have a serverless component that is going to be activated by pulling something off of a message queue, maybe that has less of a direct invocation concern, but you do need to back up and say, whatever showed up in this message on the message queue, where along the way were certain functions performed? Where did I do my input validation? Do I have proper encoding as data is passed layer to layer? And so again, this is an opportunity to provide guidance via these threat model templates to developers. And as I said, there are challenges for naive or unsophisticated attackers versus web applications. From a crawling standpoint, with the web application, you can start at the beginning page, see if you can log in, crawl through. That's less the case when a lot of these things are essentially sitting behind an API gateway, and so that's good. One of the things that we found in certain organizations where they don't have really tight controls, or where they have very coarse-grained controls, or they're creating really large VPCs, that increases or should increase your concern about insider threats. When you look at what are the different systems that may be inside of this VP, if you're not using a lot of segmentation, that's going to increase your concern about insider threats. And also, I harp on it because I remember that I created the name, but you have concerns here that are different than in other areas where you have this concern about financial resource exhaustion on top of concerns about denial of service, where this is an area where attackers may have a greater ability to directly impact the cost of your services versus in other configurations or other setups. Or do you want to maybe talk a little bit about what you all do from a threat assessment standpoint?
Yeah, I actually wanted to go back to something that you mentioned that I found very interesting about the fact that you have a serverless function that gets triggered by maybe a message that comes into a message queue and not necessarily directly from a user. I think I'm hearing a lot of organizations talking about the fact that their serverless functions are not exposed directly to users, hence the risks there are much lower, and so they sometimes deprioritize the security of those systems, and that's obviously a mistake. Mostly because in those cases, the data comes from somewhere into the message queue, and the threat modeling that they performed was obviously not correct or not accurate, because as you mentioned, it could be like a multi-step or like a second-order attack where data goes into a bucket and then gets pushed into a queue, and then the queue triggers the function. So yeah, the function is not directly exposed to the users, but data can still flow in. And so this is something that when people do threat models for serverless applications, they have to think about where data is coming from in the beginning and where it ends up at the end, and not just, okay, here's the function, that's the compute, this is what I'm looking at.
Very good. And when we look at security requirements, honestly, this is an area where serverless doesn't necessarily have a huge impact other than understanding the security capabilities of the platform that you're working on and some of the different threat profile that you have. And again, one of the things where we have found is an ability with serverless is building these explicit access control matrices for the serverless components of the system. And so, yes, you need to pay attention to the security requirements. Those need to be applied to the serverless components of the system. Not necessarily that much has changed because of the introduction or the availability of these serverless capabilities. When we look from a secure architecture standpoint, again, these cloud reference architectures with the explicit security guidance can be really valuable because they give development teams a starting point from which to work. And that's and that's something that's really valuable, again, when these developers are fighting the learning curve from an architecture standpoint, to be able to provide them with guidance. Gets them to think about the problem in the way that you would like to have them thinking about it. One of the great things about serverless, cloud and security, or in serverless specifically, is you have the ability to provide very fine-grained architectural security controls by setting up different accounts that have different capabilities, constraining things within VPCs, setting private networks between different components. And so you have the ability to do some really great things from a security architecture standpoint, controlling how data flows between different components and who has access to it. You can also really mess things up. So congratulations or good luck or whatever whatever that message is. But that's one of the things we found in certain environments is they get very elaborate with very fine-grained controls, and that's fantastic. If you can manage the complexity associated with that, and that's very much the case with serverless. Really, if you have an understanding of how the components of your application fit together, how data needs to flow, that allows you from an architecture standpoint to put in a lot of controls. Looking from a verification standpoint, your design review. This is tough to be actionable, but one of the chief things that we've found is that the folks leading these design reviews need to be smart about a number of different topics, not just about serverless specifically, but all of the things that serverless touches. Because you want to you have to know how a number of these things are going to fit together if you're going to understand the security of the system. So that places a little bit of a higher knowledge barrier on the folks that you want to lead these types of these types of efforts. You want to make sure that serverless components are included in the application attack surface reviews. When you think about what are all the things that can be attacked, what are the components of the system, you want to make sure that serverless components are included there. And again, the platform administrative tools can help with this. The flip side of that also is a concern. You want to make sure that in addition to serverless, that the other components are included in the attack surface review. I'm thinking to an architectural assessment that we were doing recently, building a threat model. We've got some technology we built that helps to automatically enumerate or automatically sketch map out what threat models look like based on a runtime agent. And we were brought in to look at this system because they said, hey, we've incorporated serverless into this. We want to make sure that we haven't done anything too crazy. And in looking at the threat model that our tools that sketched out, we found that it was not just an AWS set of Lambda functions that were in use, but there was also an S3 bucket, which was something that wasn't necessarily generally known to the security team. So we went to the architect, and the architect said, oh, well, yeah, there's certain file transmission limits associated with AWS Lambda, so we're also using this bucket to communicate the bulk of the results. Again, totally fine in the end, but that knowledge of the system, the perspective of the security team was, we're using serverless, did we do that right? The actual implication was, we're using serverless and this other technology. Let's make sure that we're using all of those correctly. Again, a good thing about these serverless platforms is, you want to have the platform-specific security controls. Those need to be incorporated into the review of the serverless components. I think also a thing to pay attention to when you look at your design review, as Ori identified, an attack against serverless systems is to subvert the code deployment process. And so you need to be looking at your CI/CD pipeline, not just the security implemented in your CI/CD pipeline, but the security of your CI/CD pipeline. That's a vector that you don't necessarily think about being as significant in non-serverless environments, but looking at that code deployment vector via a compromised cloud account, that's something that you need to pay attention to. When we look from an implementation review standpoint, you need to adapt your code review practices to work in your serverless components. And that composes both language-specific, understanding the different languages that you may be writing serverless components in, as well as the environment-specific. How does AWS handle this differently than Azure? And you also need to adopt the code review tools that you're using to make sure that they're effective in serverless environments. And so a lot of this comes down to understanding how these components are going to work and how they get invoked. Maybe I think the code review capability is a pretty integral part to the stuff that you're doing. I don't know if you want to talk a little bit about that.
Yeah, just very quickly, because we don't have a lot of time. It is capable of scanning your function source code as well as the configurations, whether it's CloudFormation or SAMM or whatever it is that you're using, in order to make sure that the roles, the permissions, and your configurations are least privileged and don't contain any kind of bad security practices. I don't want to take more time, so let's just continue.
Oh. And then we look at security testing. And again, this is a case where you've got to adapt both your testing practices and the testing tools that you're working. And I think this is something where if you look at taking a standard web application fuzzer, none of the ones that I know in the market right now are really in a situation where they're ideally suited to fuzzing these components individually. Obviously, if you fuzz a web application then talks to a serverless function down the road, you can impact those. If you think of adapting a typical web application fuzzer to a serverless environment, you have a lot of the trouble that you have in general with testing APIs taken to an even further level.
Actually, I published a few months ago a sort of a bridge connector that allows you to scan using SQL map and scan serverless AWS Lambda functions natively through the AWS SDK. So that's the only one I know until today.
Very good. Yeah, and that's something where the tooling, tooling is just now coming online or just now starting to be out in the marketplace versus the comparative maturity of testing more tried and true architectures. From an issue management standpoint, again, this is an area where the serverless doesn't necessarily have much of an impact. You need to make sure from an issue and incident response standpoint that those plans include the required access. So you need to be able to, again, if you're used to taking code out of Git and deploying it onto a cloud server or a local server, this is a different deployment, configuration. So you want to make sure that serverless is included in that, but from an architectural standpoint, there's really not a lot of changes in your environment based on serverless. For environment hardening, good news. You no longer have to patch servers. You don't have to harden. You no longer have the responsibility nor even the ability to do a lot of environment hardening tasks that you maybe used to be responsible for. But this is an area where, from a serverless standpoint, we've talked a lot about the code. This is also looking at the configuration. How do you use the platform-specific guidance the platform-specific controls and capabilities in order to harden these serverless components? And this is also an area where, wherever possible, you want to automate the hardening and verification in the deployments, based on the serverless stuff. And so again, as code is deployed along a different vector, you need to make sure that the deployments going along that vector implement the appropriate security controls along the way. And also in this case, API gateways have some built-in capabilities for rate limiting and other controls, and that's good. But as Ori mentioned earlier, if you're concerned about things like denial of service, the standard settings, 1,000 concurrent accesses or whatever that might be, that may be appropriate. It may not be appropriate, but that's something where these serverless environments do give you some ability to control or to shape the environment to get the trade-off that you want. Are you more concerned about somebody trying to take money from you or exhaust financial resources, or are you more concerned about a denial of service? You can use the platform to bake in or to implement those types of controls. And Ori, I don't know if you have any additional thoughts about the runtime, your runtime environment hardening.
Yeah, so part of the PureSec platform is obviously protecting the runtime environment. There's also a question here whether that's relevant, whether the code that is injected as part of the PureSec runtime protection is for the firewall and supports multiple languages, and is it the same mechanism for the anomaly detection? So the answer is yes. From a language support perspective, we right now support the top most common languages: Python, Node, JavaScript, C#, and Java. And it is the same library. You don't, as I mentioned, you don't necessarily have to inject it into the code. You can simply point to it using the Lambda layers capability, so it's just a configuration change. I did want to comment on the fact that, as we move to serverless and we get higher into the abstraction of the cloud, obviously people heard about infrastructure as code. And the whole IT and IT security is going to have to go into the area of verifying infrastructure as code snippets, because that's basically the infrastructure today.
Excellent. And then finally, looking at here, the operational enablement. And the big change that we've seen here goes back to something I mentioned earlier, which is there's kind of a different set of people that need to be involved. It focuses more on the developers who are writing the code, the DevOps folks who may be setting up the infrastructure configuration as code, or the configuration of the environment as code. That's as opposed to previous communication patterns that may have been, well, security needs to talk to network or operations. Now those folks have been are not necessarily in the picture. Hopefully they've all moved to get jobs at Amazon, or depending on how advanced your transition is. And so you're likely to be talking to a different set of people than you might have been used to talking with before. And that's an important thing to recognize, especially in organizations where you're pushing this cultural transformation of DevOps and DevSecOps to make sure that you've got the right people in the loop. And from an information standpoint, you want to make sure to incorporate serverless logging into the environment and the change management. And Ori, I don't know if you want to talk a little bit about from a visibility or from a logging standpoint, some thoughts there.
So there's a lot of visibility options that cloud providers provide today. If you look at AWS as an example, obviously CloudWatch and CloudTrail for monitoring cloud APIs, and then there's the new Security Hub, and there's plenty of solutions. However, if you do want to have forensical information, forensic data on the application layer itself, and what's going on inside the serverless runtime environment, you will have to either build it yourself and do much better logging at the app layer yourself, or obviously use some kind of serverless security platform or serverless observability solution that's tailored for those specific issues.
Excellent. So we're right up about an hour here. So if folks are doing this over lunch or something, you may, people may need to drop off. We'll be obviously sending out a recording of this here before too much longer, but wanted to open up the floor for any questions that people had. If anybody has questions about any of the things that we've talked about, or questions about your experience in your organization trying to roll out or take advantage of serverless technologies. One question about how is serverless security different than kind of standard web application security? The one point that Ori made that I thought was really valuable was kind of making sure to state from an application security standpoint. I think you've got a wider variety of concerns, but in serverless you're worried about like the code and the configuration of how that code works. Ori, I don't know if you have any additional thoughts about what you've seen just kind of with your experience from in web application environments and through the work that you've done beyond that, and then now looking specifically at serverless, if you've got some thoughts on that.
Yeah, so there's really no point in separating the two. Serverless is a way to build and deploy applications. So we are talking about application layer security. It's a good thing that we got rid of all the underlying infrastructure and network security worries in that sense. However, obviously there's a twist to almost everything when it comes to serverless. We talked about the attack surfaces can be quite different. The input vectors, what can trigger your code, the fact that you would usually build serverless applications as microservices or nanoservices, which brings with it its own different bag of problems. And obviously the infrastructure as code considerations that are different, and of course the scalability and how you design the backend for your the backend cloud services, how you consume them, how you interact with them is quite different, especially if you're trying to use message queues as sort of like buffers between the compute and the backend. So there are different things. It is application security, obviously, but I do urge people to read the top 12. I think it covers this topic extensively.
Very good. Could you point to recommendation of serverless templates to hand to developers? So that's something that we've put together at Denim Group, working with a number of organizations. We've put together some templates like that, particular to those enterprise environments. And so looking again at their data classification policy, their application risk ranking policies, their cloud, what are the allowable cloud components in their particular environment? You can use these cloud services from these cloud providers. So that's something that we've put together on a bespoke basis for a couple of organizations. I think we're looking to hopefully be able to publish some of that stuff in the future, but right now right now we don't have we don't have any of that in a publicly consumable fashion. But that is something that, again, based on some publicly available information and whatnot, you can hopefully do given an understanding of your organization's data classification policies and your organization's policies on which providers they're allowing applications or they're allowing development teams to use. Another question here about how much of security testing is possible and allowed to do by the cloud service providers in terms of applications. That's something from our side. We're typically doing, going through the notifications, the notification process that you have with the various cloud providers to let them know we're going to be testing this system, with this time, and obviously following their rules for things. If they have rules for no denial of service attempts and things like that. And so, really, when we do testing, we've piggybacked that on top of the cloud providers, just their standard requirements that they have, both for notification for them of when you're going to be doing testing and potentially the type of testing, and then obviously following their restrictions overall on the types of testing that are acceptable in their environment. And then finally,
here, yeah.
Let's see, and then another one. Where can I find information and best practices on serverless security? Ori, you've mentioned a couple of these along the way. I don't know if you want to sum up. I know you guys have published a lot of materials in this space.
Yeah, so we've been doing that for a bit over 2 years. There's the top 10 guide. Just type serverless security in Google. I'm pretty sure the first thing that will pop up will be our blog or our website. There's a ton of materials there. We recently published a very good ebook, AWS Lambda Security Best Practices, which covers a lot of the things we've talked about here. With going more specific into the different services that you can use on the AWS platform. But I think that the PureSec blog, and there's also an awesome list on GitHub that I'm maintaining called the Awesome Serverless Security. Just look for that in GitHub. And it has really dozens of terrific resources that I recommend that people should read.
Very good. Well, I think that's all the questions that we've gotten. We're running a little over here. which is fine. I'm having fun. Hopefully, or you're having fun, and hopefully everybody else is having fun.
Always.
But probably need to wrap it up now. Again, thanks to everybody for attending. Thanks, Ori, for participating in this. As I said, serverless is an area where we've been doing a lot of work from the consulting side, and have really enjoyed helping organizations with that. We've been really impressed with the stuff that you guys are doing, and so and the resources that you've provided out to the community. So thrilled to have the opportunity to talk with you today.
It's been an honor.
We'll be getting a recording of this out if folks want to review it or pass it on to their colleagues. That should be here within the next day or so, I think it takes. Again, thanks to everybody for attending, and hope to catch you here soon.
Thank you.
Thanks, everybody.
Bye-bye.